Hello, my favorite bilingual students. If you remember, exercise 2 was a special type of circuit. Type of circuit we haven't been doing yet. And it's called combination circuit. It had 3 resistances. Resistance 1, resistance 2, and resistance 3. And we know the values of these 3 resistances. And I think there were 12, 10, and 40 ohms. And we also knew the total voltage of the battery, 40 volts. And we need to calculate all current through all resistances. I1, I2, I3, and voltages in every resistance too. How can we solve this type of problem? First of all, we need to understand the meaning, what's happening really here with current and voltage. And to understand that, we can go to our idea of a battery like a water pump and an electrical circuit like a water circuit. In this case, remember, this battery gives energy to the water. Potential energy given heat to this water. So this heat is the total voltage of the battery. And what for this potential energy? To transform it into kinetic energy to be used in this water wheel. This is R1. All the current that comes out of the battery passes through this first resistance. But after it, we have 2 different ways for current. That lead us to resistances 2 and 3. And current can be pumped up again to restart the circuit. This is, I think, a very clear image of what's happening in this combination circuit. Let's take a look. This difference in height is the voltage of the first resistance. And here we can see that resistances 2 and 3 that are connected in parallel have exactly the same voltage. And if we add voltage 1 and voltage 3, or if we add voltage 1 and voltage 2, we obtain the total voltage of the battery. Let's take a look to the different heights. What happens with current? The total current that comes out of the pump passes through the first resistance. So total current and current 1 are exactly the same number. But after these resistances, the current splits in 2. So current 2 plus current 3 gives us current 1 or total current, the same, okay? Well, we can apply these ideas to our circuit. To calculate everything in a combination circuit like that, we must follow exactly these steps. First step, as we have 2 resistances connected in parallel, we need to calculate the equivalent to these 2 resistances. Let's call it apostrophe R, for example. We use this formula, you probably remember, to calculate the resistance, equivalent resistance to these resistances connected in parallel. In this case, 1 over 10, 1 over 40, 4 and 1, 5 over 40, so 8 ohms is the equivalent resistance to these two resistances connected in parallel. In fact, we have something like that. A circuit with two resistances connected in series. One of 12 ohms, resistance 1, and one of 8 ohms, the equivalent to these two resistances connected in parallel. Once we have this, the second step, it's clear. Let's calculate the total resistance. As these two resistances are connected in series, we simply add their values. So 20 ohms, this is the total resistance of this circuit. Well, knowing that, we can use Ohm's law. You all know Ohm's law is this really famous formula. And in this case, we can apply the formula to the total voltage of the battery and the total resistance of the circuit. And we can calculate the total current. Total voltage is 40 volts, total resistance 20 ohms, so total current is 2 amps. And remember, the current that passes through resistance 1 is exactly the same. So current 1 is 2 amps. And we have the first answer we needed in our grid. Let's go to the fourth step. In the fourth step, we can calculate the voltage in resistance 1. Remember, we know current and we know resistance, so we simply multiply 2 amps and 12 ohms, 24 volts. This is voltage 1. And you remember, voltage 1 and voltage 2 gives us total voltage. So we simply, in next step, calculate voltage 2 or voltage 3, total voltage minus voltage 1, 16 volts. Perfect. We only need to calculate currents, and currents are voltage over resistance. So again 16 volts, the same voltage, because R2 and R3 are connected in parallel, and excuse me, and we can check both currents and calculate the total current, 2 amps. So we did it right. Okay? Well, if it's understood, I'm going to give you a paper with 3 more combination circuits. Some of them quite tricky. So you can think, calculate, and try to find the right answers. Here we can complete the grid. Remember. Thank you for your patience.